Hi, welcome to Nomics Academy. In this video, we are going to learn how to find the gradient of a curve at a point. Now we are considering application of differentiation. In my previous video, I've explained the different steps or procedure in finding the derivative of a function. So we are going to be using those concepts in finding the gradient of a curve at a particular point. Alright, we have an example on the board. Find the gradient of y equal to x squared plus 3x minus 5 at the point x equal to 3. You will agree with me that the gradient or the slope of a curve is given as dy dx. Alright, so we are going to find the derivative, which is dy dx of this function, and then we slot in the value of x at the point where we have x, and then we get the value of the gradient. So, solution, let's start with solution. The function given is y equal to x squared plus 3x minus 5. Alright, the gradient of this curve is going to be dy over dx, which is, when you differentiate the function, x squared becomes 2x, and then 3x becomes 3, and then minus 5 becomes 0. I've explained how to differentiate in the previous video, so you can go back and watch the previous video to give you the concept of differentiation. Alright, to continue with the solution, now the curve or the derivative of the curve or the gradient of the curve at the point x equal to 3. Okay, now we are looking for the slope or the gradient of the curve at the point x equal to 3. So here we have 2. In place of x, we put down what? 3 plus 3. So dy dx is equal to 2 times 3 is 6 plus 3. So the final answer, dy over dx, is equal to 9 units. Alright, 9 units is the gradient of the curve given. Alright, let's pick example 2. Example 2. Say if y is equal to x cubed plus 3x squared minus 9x plus 5. Find the points at which the gradient is 0. Alright, if the function given, then find the point at which the gradient is 0. So we are asked to find the point. Mind you, we are asked to find points, not just a single point, but the different points at which this function or at which the gradient of this function is equal to 0. Alright, solution. Solution. Now the first thing we need to do, we are going to find the gradient of the curve, and that will be y equal to x cubed plus 3x squared minus 9x plus 5. Now find the gradient of the curve. Gradient of the curve is dy over dx equal to, differentiate x cubed, then you have 3x squared. Differentiate 3x squared, you have 6x. Differentiate minus 9x, you have minus 9. Differentiate 5, then you get what? 0. Now we say at the point where the gradient is equal to 0, we are asked to find the 2 points, or the point where this function or where the derivative is equal to 0. Now to do that, we are going to write x 3x squared plus 6x minus 9 is equal to 0. So at the point where dy dx is equal to 3, we are going to find the 2 points. Alright, because 2 points because we have a quadratic equation here. So to factorize this quadratic equation, as we can see, 3 can divide throughout the equation. So that will be 3 divided throughout, we have x squared plus 2x minus 3 equal to 0. So now let's factorize the quadratic equation, and that will be x squared. We need 2 factors of minus 3x squared that will sum up to 2x. And those factors are minus x plus 3x. So minus x plus 3x will give me plus 2x. Minus x times 3x will definitely give us minus 3x squared. So these are the 2 factors of the product. So we now have minus 3 equal to 0. Now to go further, pick the first 2 and factor out what is common. We have x into x minus 1. And then here we have plus 3x minus 1 equal to 0. So at this point, we pick what is common, x minus 1 and x plus 3 equal to 0. Now the next thing we need to do is equate each of the linear factors to 0. X minus 1 equal to 0 and x plus 3 equal to 0. Here the value of x is equal to 1, and here the value of x is equal to minus 3. Now we need to get the y value that corresponds to this. The next thing we need to do, pick these 2 values and slot them in the function given to get the corresponding values of y. So to do that, I need to clean up this side. Alright, so we put in x1 and x equal to minus 3 in the function given to get the corresponding value of y. So we have when x is 1, we have y equal to, we slot in 1 there, 1 raised to the power of 3 plus 3, 1 raised to the power of 2 minus 9, x is 1, and then plus 5. So y is equal to 1 plus 3 minus 9 plus 5. So that will give us 1 plus 3 is 4, 4 minus 9 is minus 5, and minus 5 plus 5 is 0. So y, the value of y is 0. So at the point x is 1 and then y is 0 is the first point. Now when x is equal to minus 3, y is equal to minus 3 into 3 plus 3 into minus 3 raised to the power of 2 minus 9 minus 3 plus 5. So we have y equals to, this is 27, minus 3 raised to the power of 3 is 27, plus minus 3 squared is 9, 9 times 3 is 27, minus 9 minus 3 is minus 27 plus 5. So we have y equals to 27 minus 27 is gone. 27 plus 5 is 32. So the corresponding value at the point we have when x is minus 3, y is 32. So the 2 points are first point is 1, 0, and the second point is minus 3, 32. So thank you for watching. See you in the next video. Bye.